Good day everyone and welcome to this second episode of Coding Series. In the first episode I showed you a simple track and trailer example, but before moving on to the third episode I would like to explain how to calculate the position of any point in 3D space relative to a root object and its rotation. In this example, the root object is a car, and any points in the 3D space are its four wheels. So we have a car, which in this showcase is represented by a box object, with four wheels, also represented by four box objects. Let's highlight one of these wheels for this showcase, and take a look at the three coordinate axes as well, visualized here with green, red and blue. And of course now we have no rotation applied to the car and we know the coordinates of the highlighted wheel compared to the vehicle's turning point. The turning point will be in the showcase the middle point of the vehicle. But what happens when we turn the car in 3D space? Well, now if we imagine our car driving around while rotating only around its vertical or y-axis, we can calculate the wheel's positions using simple 2D mathematics. Because as you see, the height of the wheels is unchanged during this process. By the way, if you like this channel, feel free to subscribe. The same applies to rotation around x and z axis as well. As you see, as the object rotates around one given axis, the wheel's coordinate along that axis does not change. But as soon as we add a second axis rotation, well, things change and we have no more single coordinate constant. This applies when we rotate the car around x and y, like now, or x and z, like now, or y and z axes, like now. Finally, if we rotate it around all three axes, well, it looks chaotic, but in fact is just a nice pattern. Back in the day, from the idea of imagining this as multiple layers of 2D mathematical problems, I tried writing different functions and took hours and days to figure out how to code this, but it turned out I did not view this from the very ideal perspective and my solution was, well, something close but of course very far from being perfect. But how to do it then? The correct approach and the correct function is where we calculate the contribution of each local coordinate to the world x position after applying rotations around all three axes. In other words, for each wheel on the object, we determine how much of its x, y and z components actually point in the global x direction once the object is rotated by the given angles around x, y and z. And the final position in world space is then the sum of these contributions. It's hard to see at first glance why these sine and cosine combinations appear. The key idea is that a 3D rotation rotates the local axes themselves. Each local axis contributes a fraction of its length to the world x, y and z directions, depending on the rotation angles. These cosine and sine describe how much of a vector points along each axis around each global axis after rotation. Think of it as projecting the rotated local axis onto the global axis. And you can imagine you have a stick in space. If you tilt it in different directions, only a part of its length points along x, y and z. The sine and cosine tell you exactly what fraction of the stick's length points along each world axis. Now I only rotate the car around its y-axis. And now you see how much each axis adds to that x-coordinate. I think it's really visible. Red means x-axis. Adding all rotations and all visual showcases of each axis gives you a nice view about what just happens. Do I know this sine and cosine formula? No, of course not, but I understood the principle of this, and I know I would not be able to figure out this on my own, and in these cases it is a good idea to look it up in a book and use the matrix tables which describe these situations. So, from a book, this is a rotation matrix around x-axis, around y-axis, and around z-axis. And the total rotation matrix in order is this. So, the total calculated matrix is the following. And from this we can nicely get our x world, our y world, and our z world coordinates. So, and if we write these in functions and apply these values to the wheels, we get nicely all the correct positions, which is also great for different solutions, not just for wheels, but for any 3D point of a vehicle in 3D space, which will be very usable in the third episode. So stay tuned, and if you like my channel, please subscribe, leave a comment, and feel free to share this video with your friends. Thank you, bye bye!